Hello everyone, my name is Paul. I work for a company in Cape Town called Micrographics. We are an Autodesk reseller, and today I'd like to focus on specifically South African coordinate system in Infraworks, Civil 3D and Revit, and how do we work with that over here in South Africa. So just as a background, in South Africa we work with a left-hand coordinate system definition, and it makes our life a little bit difficult within any design software that we use, especially the interoperability. So I'd just like to show you how that works. I do have a site in Cape Town that we can use, but it's very close to sea level. So I'd just like to sort of randomly pick a place up here in the Highveld where we're dealing with a much bigger height difference between sea level and the actual project level. So let's quickly have a look at where we can choose something over there. We've got a river that runs through it over here, and there's the road that travels up here. So when I locate this area, it goes up the mountain. This is where we want to be, and I had a look at this before the time, and I just want to set up some other imaginary site up here. So we'll choose to draw a rectangle up here. You can see it's quite small, 0.3 square kilometers. We can maybe choose an area that's a bit larger. Let's choose something like this. It's 2.9. Let's go a little bit bigger. There we go. That's quite a large area. Maybe that is too large. Let's do something like this. That should be interesting. There's a 1.52 square kilometer area. We're going to create a model name. Easiest is, if you are going to be storing it in the cloud, then you want to give it its correct name. The description is and the coordinate system that we'll choose is then a Hartbeeshoek coordinate system. So if you look at where we are working, we are in zone 27. That's this blue zone over here, and we are operating up here somewhere. So that's the blue zone over there, that's 27. And we can then go and set this to Hartbeeshoek load 27. We'll create that site, and then that Infraworks model will be available to us. Now, if you did have access to some further databases, then you could of course get much more accurate topography. In our case, we're going to rely upon the Infraworks model. It's very inaccurate topography, but it does illustrate the point. We're going to go from Infraworks to Civil 3D ultimately, and so that is what we'd like to see. Okay, so here we go. Our model is ready. We can open our model, and in this case I'm going to save it up to Autodesk Docs. We browse to the relevant folder and we save that file up there. Great, and then after we've opened it up, we can see we've got some nice topography here. There's a bit of a mountain going on, and up here there's a road. It's close to a radio tower over there, but let's suppose for argument's sake we want to put up a little bit of a guest house or something over here, then that would be a nice place for us to start. We've got our topography, and we'd like to bring this into Civil 3D. So that's where we're starting. With an Infraworks model, we've saved the Infraworks model into the cloud, and then we'll link the topography, or we'll bring the topography into Civil 3D. Here we are in Civil 3D. We're going to start a new file from, I've got the South African country kit, the template, where they've already rotated the coordinate system 380 degrees. So if you have a look at your view tab, if you switch on the view cube and the nav bar, and if you go to UCS man and you switch on the coordinates, the UCS to display the coordinate points, it's on. And if you switch out to a 3D view like a wireframe instead of a 2D wireframe, you can see Y is pointing south, X is pointing west, exactly according to the South African convention. We just swap X and Y. But anyway, let's not get caught in the complexities of the South African coordinate system. Let's just fix on exactly what we need to do to get our project up and running. Alright, so what I normally do is I draw a circle from 0, 0 with a radius of 4,000 kilometers. That zooms it to about this extent. And then on the survey tab of the tool space, we on the settings tab of the tool space, we can right click on our drawing, we can edit the drawing settings, and we can set the coordinate system to, I think it's Republic of South Africa, that's right. And then under Republic of South Africa, Hartbeeshoek, it's the zone 27 that we are working in. Okay. And then on the geolocation, let's switch the map on. I'm going to go with Esri. Alright, so it's going to be somewhere over here. Let's switch out from OpenStreetMap to satellite imagery, Esri imagery. Right, and here we can see the area that we are interested in. And so what we will do over here is just draw some lines. F8. We'll draw one line horizontal and one line vertical. And then to make our life easy, we'll change the values over here on the start X and the end X to be some easy to work with numbers. Same with the horizontal line. It's going to be the end Y. And let's offset that by, I usually just use something like 500 meters. That's a kilometer by kilometer. And I draw a line that represents somewhere the north arrow there. And let's clean up the drawing a bit. So this now gives us our easting and our northing, our reference. The other thing that I do is I draw, just for my own sake, a line from that tip of the end, from the north point to the origin. Just have to make sure that I'm not drawing in a relative coordinate system, so let's put in hashtag hash 0, 0 to make sure we're going all the way into the origin. We zoom to extents, then we can see we're pointing all the way to the equator. That's the false northing, but there is our site that we are working on, right over here somewhere. There we can see the radio towers, and just north of that, nice nature reserve. We might want to put something over there. So it's just a imaginary situation that we've got, but that's the basic idea to start off with. Let's save this file. We're going to save this file as also a cloud file. File save as, and then we'll take it into docs. And now the next thing we need to do is in South Africa, we need to do a coordinate transform. It's also on the settings tab. Right click over there, edit the drawing settings. So if you want to do this correctly, without error, switch on the transform. Say here that the reference point is 0, 0, 0. That you're rotating about the 0 point, and a reference angle first of 90. So we first go with 90. Now you'll see what happens with the imagery is it's rotated through 90. There it is. What the model is rotated through 90, and then we'll do it another 90 degrees now. So we'll once again do the rotation. We do it in 2 steps, otherwise the image inverts. So first 90, then 180. And then we also need to rotate the model physically. So we're rotating our model about the origin. We'll rotate about the origin 380 degrees. Now the only thing that we have to live with over here is that north points south, south points north, but our site is correct. After that we can get rid of the line pointing to the origin and the circle on the outside that helped us locate the imagery. Let's zoom to extents. And let's switch off the imagery. We might also be interested in just putting some northing and easting value down here, so we'll do that. Okay, so this vertical line, we can see the X value is 62,400. The Y value is minus 76,200. Right? And just double checking, we can see that our coordinate system is set to RTS hook zone 27. So that's correct from a Civil 3D perspective. So this value that I've put in here in plain text, that'll be easily read in Revit. So this would be a file that you can start with in Civil 3D. Now we also have to bring that into Revit. Alright, so let's see how that's done. We'll save this file and close it, and then we'll see how that operates within Revit. So what we have here is a Revit model. It doesn't yet have its coordinate system set. I've created it as a cloud worksheet model, so it's on Autodesk Construction Cloud. Now I'm creating a workset for the linked CAD, and now when I bring in my CAD link, I'm going to link in the file from Autodesk Docs, the one that I saved there. Quickly go to our work in progress folder and grab our file, save from Civil 3D. That's this one over there. How are we going to bring it in? We're going to bring it in, the import units over there is meters, I know that. And then we're going to bring it in center to center. It will sort of be in the center to the center oriented view, and we put it on level 1, basically the 0 level, and we say open. Okay, and there we can see our coordinate system. Let's put it in place. And let's acquire the coordinate system from manage. Here's acquire coordinate system. Click on the DWG link. It says the coordinates have been acquired. Let's report the coordinates. Just as a check. So report the shared coordinates from this line over there. You can see 2706, 200, and then 1000, so that's correct. That should be less because we're going in a negative direction. So that's 57. 2705, yes, and that's 27067, 27062, 27057. So that's correct. It's going up and down in 500 increments. And this is 62400 going into 62900 and 61900 on that side. So that's also correct. That's then our coordinate system set within Revit. And this is the site container, so we just want to bring in the topography at true elevation. We'll do that next. Right, so here we are back in Civil 3D. We're now going to open an Infraworks model. It's in our documents folder. If you know where to find it, you can browse to that. You can open that file, and then when we set the coordinate system, we have to make sure that the transform is off. We'll set the coordinate system, and we'll switch off the transform. Coming into Hartbeeshoek 27, and then we'll refine the selection set. And we'll only bring in the existing topography. And then we're going to have to rotate it through 180 degrees again. I'm also, just to make my life a bit easier, going to switch out to 2D wireframe. Going to switch off the geolocation. And then I can see we've got our site over here. And there is our topography. So we'll select the topography and rotate that. Home, rotate the topography about the point 0, 0 through 180 degrees. And we should find that these two are pretty close now. And let's switch on the topography, the map, have a look. Right, so obviously something has happened to throw out our imagery. Let's see if we can fix that. If we go to the settings and we right click on the drawing and we edit the drawing settings, and then we have a look at our transform. So you can see that the transform has been reset over here. Let's apply a transform. Let's change that back to 0. And then let's give it a grid rotation. If we give it a grid rotation of 180, you'll see what happens. It'll properly flip the picture. Let's see. Okay. There you go. No, it's in place. So that's perfect. This is now our, we can see if we zoom in close, how the topography is very much aligned to the satellite imagery. We've got the saddle over here. So that's perfect. Right, so this is with regards to Civil 3D. We've got the topography in. We had to rotate it through 180 degrees from Infraworks. So the next thing we need to do is we need to untransform the drawing if we want to export the topography. So we'll go to the transformation and we'll switch the transformation back to 90. And then we'll do that once again and switch it back to 0. And then what we'll do is we'll go to the Collaborate tab. We'll publish a surface. We can publish the existing ground surface, and then we just have to say where do we want to specify the output file. We're going to put that into our Autodesk docs in Micrographics under our work in progress GX. I'm going to save it in FX2 because I know this folder isn't name enforced. And that's going to be called FX98 FX2 GX005.shared. That should do. Yep. Okay. Publish with the updated style. Let's do that. Right, so here we are in Revit. We're in the site plan. Now we're around about 2 kilometers above sea level. So in our view range, we'll now go and say that our cut plane is about 2.5 kilometers, unlimited up and down. Okay, and then we can link that topography in. There it is, 98. Let's link that, and then we can see that the topography comes in correctly with regards to Revit. And then of course in Civil 3D we can just go and reset the transform. Take it through 90, and then we take it through to 180, and our Civil 3D drawing is back to where it should be. We can save that and close. Every time that we publish a surface, we'll do that like that. Just undo the transform and then export or publish the surface. And then in Revit, we can just link that surface as is, and it will then be where we need it in our project. There we can see our linked topography. Okay, so link topographies are a little bit different from CAD, that we manage in a different way, but this is definitely one of the very easy ways to get your site model going. Here we can see what the site looks like. We switch off the contours on our topography. Here's the topo solid. Let's do the primary contours. Okay, this makes it a little bit lighter. If we take the major contours off, there we can see our surface much more clearly. And now we can use this to go and set up our, this is our site model, so whatever, for those of you that understand how to take this process further, we won't do that today, maybe in the next blog, but we'll the next idea is then to bring the buildings in. And how do we do that is we link this topography file, this site container, into the drawings, into the models that we want to host in here, and then we acquire the coordinates from this Revit file. Okay, so in conclusion, it's a bit of a workaround with the South African coordinate system, but it is possible to have Revit and Civil 3D talk to each other and to have some interaction between Civil 3D and Infraworks. Until next time, enjoy Revit.